So machine learning. So it's divided into four categories based on the ways in which we can train the machine. First one is supervised learning. Second was unsupervised learning. Then we had semi-supervised learning. And last one was reinforcement learning. Okay. Now what we are going to see in today's lecture is this portion, supervised learning. So supervised learning is a type of ML where the model is trained using labeled data. Labeled data means, so we have seen that uh, features and labels are there in data set, and feature are basically input variables, labels are actual output. And the model will learn the mapping of input to actual output and predict for the unseen data once it is trained. In supervised learning, we have two types of tasks. Okay, so let me continue in the mind map itself now. Type of tasks in supervised learning. First is regression. Second is classification. So these are the two types of tasks in supervised learning. So we'll come to these later. Before that, let's see the type of data which we can use in supervised learning. First is structured data. Structured data means when I talk about CSV files and Excel files, so where the data is structured. So there are various ways of structuring the data, even JSON file, XML file. I mean, these are all the examples of structured data where all your data is, properly structured. Second is,
Database are also
yes,
part of a
yes,
structured
yes.
data.
Right, right, right. So most of the thing that we are doing in our, regular organizational related works, so most of them comes under structured data. Then we have text data. Now, talking about text data, it can be sentences and review documents, etc., where the data is pure text. Then we have image data also. Image data, so pictures, for example, picture of cat and dogs are basically used for training the models, right? So image data is also one type of data that is used in supervised learning. Then we also have audio data. So sounds or speech, voice to word transcription. So in all these use cases, we use audio data. The next is video data. Video data means it's just the sequence of images, right? So video is formed when we combine sequence of images one after another. Then next is time series data. So data over time. So I mean, the data that we record over the time. So influx DB is one of the example of time series database, right? So whenever we are using the data which has the past data as well, I mean with respect to time, then that is known as time series data. So that is also one type of data that we use in supervised learning. And then hybrid data or mixed data. So it basically consists of structured as well as unstructured data. For example, social media post and then I mean combined with the user information, text, images. So all these data constitutes hybrid data or mixed data. Okay, now coming back to the types of tasks. So regression and classification are two types of tasks that are there in supervised learning. For regression, regression basically means when we predict continuous value. Example, so we have data of house pricing that we have seen yesterday, right? Data set that we have seen yesterday. So we have house price given in that data, right? Now, when our model learned from that data, it will, and our main aim is basically to predict the prices, right? So whenever you are predicting the continuous value or whenever you are predicting something numerical or number, so that task basically comes under regression category. And for classification, so classification is about predicting categories or classes. Example, so classifying the mail as a spam mail or non-spam mail. So this is true or false kind of situation. Or it can be, predicting the class also. Class, when I'm talking about class, so let's say I have a animal class and I have decided three categories, right, to predict, mouse, cat, or dog. So the final prediction that the model will do will be out of these three categories only, nothing else. So whenever you are predicting categories or class, it comes under the classification task. And whenever you are predicting, continuous value or something which is a number, that comes under a regression task. Now, regression and classification both, they are divided into two categories. First one is, okay, let me write down categories first. So first category is linear category, second is non-linear one. Similarly, classification is also categorized into two categories, linear and non-linear. Now for linear category, so for now you just understand that linear category or linear, you know, under regression, linear means predicting using a straight line and non-linear means predicting using a curved or a complex equation. Similarly, in categories, under the classification, linear means it separates the class or categories with a straight boundary. And for non-linear, it means it separates with curved or multiple decision zones. For right now, you might not be able to connect it, but for now, just understand the definition. And then once we will do some hands-on or mini project, then you will, come to know what exactly these terms mean. Now, talking about regression, let's, start with regression. So regression, as I said, is a task which is to predict a numeric output from given inputs. And that prediction happens using different algorithms where machine learns relationship between input and output. And these algorithms that are used to predict the output are known as regression algorithms. And again, so it is divided into two categories, linear and non-linear. So that we have already covered. Now, talking about the linear algorithms, right? This one. So we have different linear algorithms. First one is linear regression. Then we have lasso regression. Then we have ridge regression. And then we have elastic net regression. So this is RIDGE, ridge regression. So today we will be covering linear regression. What is linear regression and how do we basically um, do the prediction using linear regression using Python. And if I talk about non-linear algorithms, so non-linear algorithm basically covers exponential regression. So these are all based on mathematical equations. So exponential, when I'm talking, so exponential equation is y equal to ae to the power bx. I'll come to that later. Then we have power regression, then decision tree regression. So this decision tree and random forest, both of these algorithms have regression as well as they are capable of doing the regression task as well as classification task. Okay, and then support vector regression. Now, when you are learning the machine learning, it's good that you can go through all these, regressions in deep, but we will in this in the current context of this course, so we will cover few of these regression algorithm just to make you understand how the machine learning happens. Okay, so we will be picking linear regression. Now linear regression is further subdivided into two categories. First is simple linear regression and second is multiple linear regression. I'll come to this part now. What are simple and what is a simple linear regression and what is multiple linear regression. Okay. So you might be aware about the linear equations, right? That you have studied in your elementary mathematics, right? Okay. So talking about the simple linear regression. So simple linear regression follows this equation y equal to I plus C C1x plus E. Okay, what are these? So y is basically the output, right? I is known as intercept and C1 is known as coefficient. X is known as input, or in terms of machine learning, we call it as feature, right? And E is error term. This is a simple linear equation is in mathematics, right? Why it is simple? And when you will draw the graph, it will be it will be something like a straight line. It will be drawn as a straight line, right? Now, why it is simple? It is called as a simple linear equation because we have only one input or just one feature. That is why it is known as simple. So when we have just one feature, it is known as simple linear regression. Now talking about multiple linear regression. Now for multiple linear regression, the equation which is there is something like this. Y equal to I is the intercept plus C1 x1 plus C2 x2 plus, so this can go on till Cn xn, and then again we will be having error term. Now here we have multiple features, right, or multiple inputs. So when we have more than one feature, more than one feature or features, it is known as multiple linear regression. Okay. Now what happens in, what we do with these equation, either this one or this one. So these are the equation that are used in regression, in machine learning. How they are used? Before that, let's revise the concepts of mathematics. Okay. When I am talking about concepts of mathematics, so first we will see with respect to classical maths perspective, from classical maths perspective. Okay, so from classical maths perspective, when we talk about the linear equation, so we have every one of us have solved these kind of equations, right? 3x1, I'm just taking some random example, right? Plus 2x2 equal to 16, and then second equation is x1 plus 3x2 equal to, let's say, 17, and we have to find the values of x1 and x2, correct? So these are the typical maths equation, or when I'm talking about linear equation, so this is the classical maths perspective. So here, what are the unknowns? So here unknowns are x1 and x2, and x1 and x2 are inputs, right? So unknowns are inputs here. What are known? Known things. So known things are y, which is output, and coefficients, right? What are coefficients here? In first equation, this 3 is the coefficient, right? We have seen in the equation C1 x1 plus C2 x2, right? And 3 and 2 are the coefficient in first equation, and then x1 here, x1, so it is 1x1. So 1 and 3 are the coefficient in second equations, right? So these are known, right? So these are known things in this equation, and unknowns are inputs, that are x1 and x2, which we have to find from these equation. And here solution will be exact, right? Exact as in, so when you will find the values of x1 and x2, it will be one value only, it cannot change, right? Based on these two equations, it will be fixed. So here solution is exact and cannot change. X1 and x2 की value will be same and it cannot change when we are considering these two equations. And here our main aim or goal is to find the solution, find for the unknown exactly. So given coefficient, all the coefficients are given in the equation, we have to solve for unknown things here, right? Now this is classical maths perspective. Let me draw a line now. Now let's see the machine learning perspective or ML perspective. Okay. So ML perspective, when we will see, so we have yesterday we have seen, right, size of the house and then square feet. So those were the inputs, right? And in each of the rows there are values for those input, right? Let's take an example. Let's say size of the um size in the square feet in the first row was 1200. So we have formed the equation 1200, and then C1. C1 is the coefficient which is not known there. Only inputs were known there. And then similarly, uh, two-bedroom apartment was there. So 2 C2. And let's take these two features only. And then the price was somewhere around, let's say 200K, 200K dollars. Similarly, for the next row, let's say the square feet is 1300 square feet and C1 is not known there. And it was a, let's say, three-bedroom apartment, and then this is C2. And the price for that particular row was, let's say, 350K dollars. And this will, keep on going for total number of rows in that data set, right? Let's say if we have 100 rows in the data set, so these equation will go till 100 times, right? Now let's see the unknowns and knowns here. So here unknowns are coefficients, right? And known things are, what are known things? X1, X2 till Xn, which are inputs, right? Inputs or features. And then Y also, which is output. And number of equation here, number of equations were equal to total samples in the data set, right? In this particular case, above case, how many total number of equations were there? It were equal to total number of unknowns, right? What were the unknowns here? X1 and X2. So यहाँ पे we have create, so total number of unknowns were 2. That's why we required two equations. These are the two equations to solve for the unknowns. But in the in ML perspective, total number of equation will be total sample in the data set, means total number of rows given in that data set, right? And here solution will be approximate solution. So value of C1, C2 till Cn, whatever we will find will be the approximate value. You cannot say that these are the exact value, because uh, if you will be basically increasing more samples in that data set, then the values of coefficient will change. And based on the prediction also, if your prediction is not good, and then when you will reevaluate your model, in that case also coefficient values will, you have to reevaluate and change the what do you say, machine learning steps in order to find the exact or more relevant, not exact, more relevant coefficient values. So here in solution C1, C2, C3, whatever you will find, the solution is an approximate solution, not the exact one. And what is the goal here? So goal here is that we have given input and output, given input and output, solve for coefficient that best explains the data, right? So this is the difference between classical maths perspective and ML perspective. Now it feels like swapping the coefficient and inputs in these equation, right? In above perspective and below perspective. You will feel like, okay, in above it is X1 and in below it is C1. So it is looking like same thing. But why we are, focusing very deeply into this concept? Uh, See, you cannot do that, right? Because by doing so, definition of unknown changes and so do the goals. So as soon as the definition of unknown changes, So here the definition of unknown is basically x1 and x2, which is input. And here the definition of unknown is coefficient. So you cannot replace C1 with X1. I mean, you cannot mix and match these two perspectives. And these two perspectives are not same, although it may look like same because we are using linear equation here. And you cannot swap these concepts, because as soon as you will be swapping these concepts, the definition of unknown changes. And as soon as the definition of unknown changes, your basic goal will also get changed. Okay. So this is the confusion which came in my mind when I was studying machine learning for the very first time. So I did little bit more research on this, and this is the best explanation, which lies where you compare the classical maths with machine learning, because classical math also uses linear equation and machine learning also uses linear equation, but there are a lot of difference in these two. So now we have seen that in machine learning, in linear regression, uh, the goal is to find the coefficient x1, x2, which are feature, and y, which is label, are already known to us. So we have to find the value of coefficient based on the test data that explains our data in a best possible way, so that when we will form the final math equation, we can, in that final math equation, we can uh, put the values of the unseen data, new upcoming data, and then we can predict the output based on the equation that forms. Okay. Now, let's take a simple use case, and let's do a mini project in Python in order to see how it all works. Okay. Let's say that, okay, you want me to take the example of simple linear regression or multiple linear regression?
Let's start with linear one because I think that would
Yeah,
be
yeah. No,
convenient
linear.
to
Yeah, we
understand.
will be taking linear one, but simple one with just one feature or with multiple feature. Example.py. Okay, let me take an example of simple linear regression ones first. Okay. Uh, okay. Before that, let's build a code map. How we will approach the linear regression in Python. I'm calling it as a code map. So code map will basically define the high level steps that I have to implement in my Python code. First step. First of all, you have to load the data set, right? Data set. Load the data set. Data set means there will be some data which first of all you have to load in your Python code, right? So this is the first step. Second step is to define the features and labels in that data, right? We have seen that yesterday. Third step is to split the data into training and test data set. So train, test, split. What is next step? Next step is to define the model. So we have we have lot of regression models, right? So next step is to select a model and define a model. After that, as soon as we define the model, we will also train the model, right? And after defining and training the model, we will make prediction. Okay, we will make prediction on test data set, because that is the whole intention of splitting the data into training and testing set, right? So that we can make prediction on test data set first. And then we will predict on new data set. Okay. And after that, uh, calculate coefficient, intercepts, and form the final linear equation. Okay, any doubt in this? I'll just pause for 20 to 30 seconds, just go through these steps one by one, and if you have any doubt, just let me know.
So this code map will be not only for a linear one, right? It will be for other one as well.
I mean, yes. Most of the things are common, but I mean, some of the things will change here and there. So
Yeah.
this is a basic flow. Now,
Yeah.
we are starting with a basic flow, so that you will understand how it works, and then we will start to implement the model evaluation steps also gradually. I don't want to include it, uh, you know, directly.
Yeah.
Otherwise, it might be creating a lot of confusion to you. Okay, so let's copy this. ओके बिफोर दैट ओके ठीक है इसमें प्री रिक्विजिट भी लेट मी राइट import so SCIKIT skykit learn is the library, Python library, which is used to uh, basically do Python coding around machine learning. So our prerequisite is to import skykit learn library, and then uh, doing necessary imports. So let's copy this code map into the editor, and let's comment out each of these, and we will do one by one. Okay. Let me see if I have scikit-learn already installed. I don't think it is installed. So let me install scikit-learn first. Pip install scikit-learn. Okay, it is installing scikit-learn library. So for that, I have ran the command pip install. Okay, so this is done. Now necessary imports we will do it later on when we will use the required methods. Now loading the data set. So here I'll be taking an example where I have a data with column advertising and then sales column. And this data will be the amount in $1,000. So one means $1,000, two means $2,000, three means $3,000, and so on. And so this is the spending I am doing on advertising for any product. And then sales represent the sales that I am doing after spending this amount, right? So when I'm spending, so this is the data that I have collected from my resources, and this is the data I want to train. So what does it represent? That when I'm doing the $1,000 spending, I am getting the sale of 1.5 in 1.5K dollar of sales. When I am spending $2K in advertising, I am getting 2.1K dollars of sale. When I am spending $3K in advertising, I am getting 2.9K dollar of sale. So this is the data that I mean, this just it's just this is an example. So this is the data which they have collected, which in real world example. So the data will be the data that you will be using is the one that you will collect from within your company or within your organization by some mean, right? So there are ways where this data you will construct this data and then finally provide it to your data to your model basically, or this is the data that you will use to train your machine learning models. So I will be using this sample data. I will train my model on this data. And then once I will do the training, my aim is to find the sales or predict the sale for new, advertising expenditure. So in future, let's say I decided to advertise, let's say for $14K dollar, then what will be the sale? So that thing will be, predicted when I will use the existing data and train my machine learning model. You got, you understood the goal here, right? If anyone has any doubt or any confusion in understanding the goal or what we are trying to achieve, just let me know. I can explain it once again.
Yeah, goal is clear. It's just that how did we understand that this will go into linear regression because we have two inputs here.
Yes.
Is that the reason?
Yes. No, 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 no. See, the thing is that, okay, first of all, linear regression is regression. We have to decide, first of all, whether it will go in regression category or whether it will go in classification category. So regression category, I told you, whenever you want to predict a number, it will go in a
Mhm,
regression category because that's a continuous value that we may be predicting in this case. So this is
mhm.
clear, right? It will go in the regression category, correct?
Regression. Yeah.
Now, under regression category, we have lot of algorithms, linear algorithm, non-linear algorithm. So I will come to that particular point when we will study the complete workflow, ML workflow for regression. In that case, what we do now, as a first step, we form a graph between features X versus Y graph. And when that X versus Y graph looks like a straight line, then that's where we decide that we will select linear regression. If after drawing or forming the graph between X and Y, if let's say that's forming something like this, right? So
Hmm.
this is a non-linear graph. So in that case, we will go and pick some non-linear algorithm and then proceed with the problem. So that is a little bit advanced thing. I just
Hmm.
want to get started with the basic thing so that we can gradually ramp up on these concepts. Okay.
Yeah.
So goal is clear, right? So let's
Yes.
create a sample data set. So data I will create in the term in form of a dictionary. You can save that data in CSV files also, or there can be many sources by which you can get that data directly from database, or as an output to some of the jobs that are running in your company. So it can be anything. But for ease of understanding, let me create this data using dictionary, Python dictionary, right? So adver This is my first column, and here I am giving the values 1, comma 2, comma 3, comma 4, comma till 10. Okay. And then second key will be sales. 1.5, let's say 2.1. Okay, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the sample data which I have constructed using simple dictionary. So it is like creating two columns, right? First one is the advertising column and second one is the sales column. And each of these columns have value 1 and the corresponding value will be 1.5, 2 and the corresponding value will be 2.1 and so on. So this is my simple data set. Now next thing, okay, before I move forward, I will be using pandas, right? Because I have to convert this dictionary into data frame also. So we have seen in the pandas that in order to create a data frame out of any dictionary, we will be using dpd dot data frame and then we'll pass the dictionary data inside that. So necessary imports, I have imported first thing, import pandas as PD. Okay. So this, I have loaded my data set as a first step. Now I have to define the features and labels, right? So as we are seeing the example of simple linear regression, so we have just one feature here, right? And what is that feature? Advertising. So advertising for me is the input in this case, and output is the sales, right? Sales is what I have to predict, so it becomes output and advertising becomes input. So I will define my input as X equal to DF, and input should be defined or feature should be defined as in as a 2D array. So you have to put two square brackets and then you will mention which particular column or which particular key you want to lock as the feature. So this is how I define my feature. So it must be in 2D. Now next thing is the uh, label, defining label. So label is defined by Y, again DF, and then sales. So I have defined my feature and label. Now you might be a little bit confused that why for features I have given uppercase X and for label I have given lowercase y, right? So the thing is that when we denote the feature and label in terms of matrices and vectors, so we define feature as something like X equal to and cy. So this is a vector notation. So in vector notation, X is represented. So this is a matrix, 2D matrix, and this is a vector. So vector is a 1D matrix. So it is one dimensional label and feature are represented as a two-dimensional matrix. So so when you are denoting your variables in matrix and vector form, so matrices, two-dimensional matrices are always represented in uppercase and one-dimensional matrix or vectors are represented into lowercase. So that is why we are following this particular naming convention where features we are mentioning in uppercase and labels we are mentioning in lowercase. Okay. Now we will be doing the train and test split. Means how much data I want to keep it for training and how much data I want to keep it for test purpose. So every data will be splitted into test and train. So let's split the feature into train and test. So X, let me call it as train, comma X test. So train and X को मैंने divided into train and test, and now let's divide Y into train and test. So Y train and Y test. So this is multiple variable assignment in a single line, right? And then there is a method train test split in sklearn.model selection. We will be using that particular method where we have to give the these parameters. So first parameter is input, then y, and then test size. So test size means 0.2, means 20% of the data from the whole data set. So from here, 20% of the data will be logged for testing purpose, and then 80% of the data will be used for training. So this is how we define train and test split. Okay. Now next thing is to define model and then train the model. Okay. So let's define the model. So we will be using linear regression. Let's take an example of linear regression. So I'll be using linear regression and I have to import this. So sklearn linear models. From this I have to import linear regression. So this is the reference variable that I have formed for this linear regression class. Next one is to train the model or fit the model, fitment of the model. So in this model, I will fit my train data, train training feature and training label. So when I am fitting the model or when I am training the model, I'll be using the training data only, right? So training features as well as training label, I will be passing in this. And I'm not passing test and, X test or Y test in this. Okay. So this thing is done, defining model and training the model, right? Is the font okay, or do you want me to reduce the font so that you can see, more text in one single frame? Let me know if you want me to, reduce the font. Okay. Next thing is making the prediction now. So I am doing the prediction. So ypred or y prediction will be model.predict, and I will be doing the prediction on X test. So in this example, this is a redundant line. I will not be using this ypred data anywhere, but when we will be studying or when we will be seeing the complete workflow of ML pipeline, then we will be using this. So the purpose of calculating this is to evaluate the model, which we will not do in this example. We will do it later on, because what I have done here is that I have trained my model on training data set, and then I am making the prediction on the testing data set, so that I will compare the effectiveness of the model that I have created here. Okay. And next is to predict on a new data set. Okay. Now, prediction on new data set. Let's take an example of new data. Let's say I have new unseen data as this. So I'll directly create pd.data frame. यहाँ पे I will give some unseen data as, let's say, 16, 17, 18. So what I am doing here is that I have trained my model on the available data set. Now I'm asking my model that, okay, you are trained now. Tell me the sales that I will get when I'll do the advertising spending of $16K, $17K, and $18K. And your model will make the prediction that when you will spend this much amount, you will get this much sales. That we will see how we will do that now. Okay, so this is the new data that I'm passing. Now for new prediction, that model will do the prediction, new prediction, it will be again model.predict, and I will be passing the new data in that, right? So this new prediction will be the prediction that will be coming from my trained model. So new, let me print this value also, new prediction, and okay. And okay, this uh, we will do in a while. Before that, let's try to run this program and see what happens here. When I'm running this program, see my data. Okay, let me put some print statements also. It will look much cleaner. Okay, it will be much cleaner now when I'll run the program. Okay, so it has executed all these steps: data set loaded, feature and label selection done, and finally it basically has done the prediction for the new data. And the prediction comes something like this, which says that okay, for uh, if you will be spending $16K in advertising, your you will get sale of $15.39K. If you will do spending of $17K, you will get this much sale. And if you will spend $18K on your advertising, you will get this much sale. So this is something which did not happen yet. So this is the prediction. This is the prediction by our model for the unseen data. Now, this is simple linear model, right? So simple linear model follows this equation, right? Y equal to I plus C1 X, correct? So intercept and coefficient. So as part of last step, we will calculate I, we will calculate C1, and we will form the final equation. Okay, let's see how we do that. Okay, so in order to calculate intercept, we will be using model.intercept. Now, in order to find coefficient, we will be using model.coefficient, and it should be the first coefficient. Anyway, simple linear model will have just one coefficient, so it will be at 0th index. And print final values of unknowns. Okay, so what will be the value of coefficient? Coefficient equal to coefficient, intercept equal to intercept, and then final math equation will be print, we'll use f string that we have seen in our Python. Final maths or final linear equation will be equation will be intercept, and then we will just consider till two decimal places. So we will write 2f plus coefficient को भी we will write coefficient okay, 1 second, 2f, and then coefficient into feature we have to write, right? So into multiplied by advertising. Okay, where is advertising? Okay, this is the one, advertising, correct. Okay, ठीक है, let's run this now. Okay, you see this? This is the final linear equation that gets formed, right? 0.11 plus 0.98 into advertising. So advertising is our input. So it is of format, right? Y, which is the sales, equal to 0.11 plus advertising is X, right? So 0.98 X. So this is the final equation that gets formed, and the final mathematical equation, as I told, right, the final mathematical equation that gets formed is known as model. So this is how you create your machine learning model using simple linear regression. Now this value of coefficient, this is a approximate value. It can vary here and there based on the model training and based on the total data set or total samples in the data set. Any confusion in this? Is it understood or is it little complex? I just want to hear your feedback on this.
Yeah, sounded little complex because it's the first time we have seen it.
Hmm.
But yeah, you have a masterpiece, the things in a good sequence. So yeah, possibly we will look into it once
So yeah,
again and
you
then.
have to, I'll share the recordings. You have to look, you have to basically go through these again and again. You have to basically start from very basic. You cannot miss the basics.
Yeah.
Every simple step is important, right? That is why I have started with a code map, and then slowly, one by one, I have implemented these steps. So just remember these. Let me paste this code map in the chat section also. Okay. So whenever you will practice on this model, just follow this code map and then slowly build the Python code on this. And whenever you'll take the example, take some other example. Some other example means you can take, there are many examples for simple linear regression. For example, you can take the example of temperature and electricity usage. Means the temperature will be your feature, daily temperature in degree Celsius, and then the electricity usage. So when in summers, let's say temperature is 40 degrees centigrade, electricity usage will be, let's say, 2 kilowatts hour. When the temperature is 45 degrees centigrade, the electricity usage is, let's say, 2.7 kilowatt hour. So this is one example that you can take. Then we can have number of hours of studies and then exam score. So hours studies, you can keep that as a feature, and exam score as a target. Then you can take, maybe you can think of any example on from your side. Experience, year of experience, and then salary. So feature will become year of experience, and then salary, annual salary will be your target. So try to take any other example and then form the code map and then do this prediction. So see, in this linear regression, it is about forming the mathematical equation, right? Linear mathematical equation, and then doing the prediction. So when you'll follow these steps one by one given in the code map, you will be able to solve it. And you have to practice on your own to become little comfortable. See, machine learning is a very vast field, and in order to master it, you have to be very strong in basics. You just don't have to study just for the namesake. Just focus on building your basics first. Even if you are not able to cover more concept, just make sure that whatever concepts you are covering, just solidify those concepts by mastering the basics. Cool. Now let's take 10 minutes break and then we will be meeting after 10 minutes. One second. Okay, let's meet after 10 minutes. Hey, welcome back. Now, okay, let me first reduce the font size. This font size is okay? Can someone confirm? Hey, are you guys back?
Yeah, it is fine for me.
Okay, now what we will do, we'll take the example of multiple linear regression and we will again build a basic flow using multiple linear regression. Okay. Now, what is the so we will take the same example, advertising spend and sales that we are getting, but instead of just one feature, we will take more feature. Let's take first as TV, advertising done on TV, radio, newspaper, and then total sales. So let's take the value as 330 point, some random values, 44.5, 17.2, 151.5, 180.8.
So with time, when data increases, this
Hmm.
equation and model both changes,
Yes,
right?
yes, yes. You have to reevaluate your model, keep on reevaluating your model.
Mm.
Okay, so let's take this example. Okay, I don't want to waste my more time on this, so I'll go to chatgpt.com. Please create a Python dictionary for this data. Okay, so I'll copy this and let me create one more Python module. I'll name it as multiple linear regression dot py. And let's see the code map. Code map remains still same. So define the features. Okay, this is all same. Let me copy this code map here. This is my code map. And I will copy these necessary imports because this will be remaining same. Okay, first part, loading the data set, right? So I've created my sample data set. Let me copy this. And then I have to convert it into data frame. Okay. So you understood what we are trying to achieve here, right? This is an example of multiple linear regression where you have, more than one features. So these are your feature and these are your samples, which says that, okay, you have spent $230K on television advertisement, $37.8 on $37.8K on radio advertisement, and 69.2K advertisement on newspaper. And you got 22.1K of sales when you have done this. Similarly, here also, when you have done 180.8K, expenditure on TV advertisement and 10.8K on radio, 58.4K on newspaper, you got, okay, this is very less. So let me change it to some good number. Otherwise, this person will die of heart attack. Okay, after spending that much, 60.9, let me make it as 60.9. Okay, just to be more realistic. So our goal is to, train our model on this data set, and for the unseen data, for the new, set of data, let's say, let me take an example that if I will be spending 250K on TV advertisement, 40K on radio advertisement, and 50K on newspaper advertisement, then what will be my sale? So this will be the prediction I have to do. This is unseen data, and this prediction I have to do so that I'll become a little smarter in future with respect to the spendings that I have to do on these categories. Right. So let's build that logic. Now, as second step, we have to define the features and label, right? So feature, we have to define it as a 2D array. So what are the features that we are defining? DF and then 2D array. And the features will be TV, radio, newspaper. Sales is the label that we will be, keeping that in. So these are my feature. And these are multiple features, right? Multiple features that I have defined. So these are X1, X2, X3, okay? And it has to be a 2D matrix, right? It has to be in 2D. Now I will define my label. Label is DF and then sales is the label. Okay, I have defined this. Now next step is I have to do train, test, split. So I'll do train, test, split, same as that I have done previously, right? So let me copy this line and paste it here. So this way I have done train, test, split, and I'm telling that in the train, test, split, keep 20% of data for test and then rest 80% for training. Then we will be defining the model. So model equal to linear regression, and we have to define model and train the model. So model dot fit, we will be training on training data set. So it is X train and Y train here that we will be giving. And make prediction on new data set. Make prediction on test data set, right? So Y pred equal to model.predict X test. This we are not using anywhere, but when we will cover the statistics part of the ML, then this will be, then this will be useful in that case. Okay, next step, predict on new data set. So let's take new data as PD dot data frame and TV, radio, newspaper. TV, radio, newspaper, and what value I have kept here? 250, 40, 50. 250, 40, and 50. Okay. So, I mean, I am giving it in terms of data frames. So this is how I create my data frame for this data, right? And then next step, okay, I'll let me write down the print statements now itself. Print uh, loading of data set done. Print feature and label selection done. Print train test split done. Defining model and training done. And have I deleted something? Sorry, my bad. Okay. Now prediction on new data set. So new data set, I have defined the new data set and then new data set for prediction. So new data prediction equal to model dot predict, and I have to predict on new data, right? Print new data prediction equal to new data prediction. Okay. What else? Let's see the prediction first, what it is predicting. Some error is coming. Most prediction. What is the error value? If all are scalar value, you must pass at index. Pass at index. Okay. Like this.
Index of 0 we did last time, right?
No. Let's see 1 second. It has to go as a single element in the list. Okay. And new prediction ko bhi I want to just display till 2 decimal. Okay, why it is not? I will do using f string. Okay. This seems correct. Why error in this? This is fine, right? New data prediction, and then we are using till 2 decimal places. Why error is coming? Okay, string pass to numpy array format. ठीक है, let's ask from ChatGPT. Okay. New prediction. Okay, so this is coming as a numpy array. So this is a numpy array. And from that, we will be, this is a array, we have to find basically the first element out of that. So last time when we did prediction, we have seen यहाँ पे ना, in this case, last simple linear regression में, the prediction came for three values and it came as three values as a array, right? यहाँ पे this we are just predicting for one value, right? I mean one sample. So it came as a array. So I have to convert this. I mean, from this array, I have to take the element at zeroth index, and then I have to do the operation. Okay, cool. So loading of data set done, feature label selection done, train test split done, everything is done. And the new prediction came as 22.48. So in this case, this value become 22.48, which is a predicted value from our model, right? Now the prediction is done. Now let's calculate the coefficient, intercept, and the final linear equation, right? Now in order to print the coefficient equal to, so here we have three features, right? So coefficient will be C1 comma C2 comma C3 in this case, right? And it will be model dot coefficient. Okay, correct. Then intercept we have to print intercept. Intercept is known as I, right? I. It will be model dot intercept, and then final model or final mathematical equation, right? So linear equation is equal to uh, okay, model intercept plus, and this we have to till two decimal places, let's say 2f, and I have to concatenate model coefficient into model coefficient 0 पे TV है, right? TV, radio, newspaper, correct. And model dot coefficient at one index into radio. Zero, one, two, newspaper, यही बना ना? Okay. But anyways, this is basically an optional step. I'm just printing it so that you can correlate how our mathematical equation is forming finally. Okay, so this is the mathematical equation that gets formed. So linear equation, so 55, okay, why it is 0? Let me remove this from here. It will be very less, I believe. Okay. So instead of it, let's keep it as still 4 decimal places here in this case. And when I'll run it, okay. Now this is the linear equation that we have formed in our example, right? So linear equation is y equal to 84.44 plus 0.0074 x1 is TV, right? Plus, so minus 1.38 is there. So it will be minus 1.38 into x2 and minus 0.17 into x3. So this is the final equation that my model has, my machine learning system had learned, and this is the final math equation, and hence it is known as our model, trained model. So this is the equation that get formed. So this is a very basic flow of multiple linear regression and simple linear regression that we have seen in the Python code today, right? Now, when you will be doing that, just make sure that you are first creating the code map. This is the code map. Code map are not, I mean, it's not a complex thing. It's just that you are simplifying all these steps, whatever steps you can think while coding, right? So you are writing down those steps and then, implementing it one by one. Okay. Now, next thing is statistics. Okay. So statistics, okay, how much time we have left with? 20 minutes. Okay, let's finish off the statistics now.
Just one question, Avinu.
Hmm.
Like line number 28 in your code.
Okay, this one.
Yeah. So how do you understand that this will go in a linear regression?
That's what. So we will come to that. So we have to study statistics first, and then we will go
Okay.
into
Okay.
that.
Yeah.
So, but I've told you, right?
Yeah.
Linear, if there is a linear, we will be, creating the map between X and Y. If it is a linear
Yeah.
map, then linear. Otherwise, if it forms like this kind of a map, then that's a parabolic equation. If like this, then it's an exponential. So then in that case, we will be selecting the non-linear models.
Yeah, I
But
understood that. But
mm,
as of now, like aesthetics is coming into last point, right? But as of now, we have not draw any diagram. Then how do we understand in advance that we need to go with linear regression in with our data?
yeah, the thing is that, so this is the basic workflow that we have seen, right? Now, when we will be covering the ML full workflow or ML pipeline, so we will consider everything in that.
Oh,
Drawing the graph between X and Y, considering the statistical concept, then calculating the error values, then evaluating our model for overfitting, underfitting, then
mhm.
taking the step. If it is underfitting, what step we need to take? If it is overfitting, then what step we need to take? So those things I will cover all at once when we will cover all these concepts, overfitting ka, statistics ka. So that part
Okay.
we will take it up later. And there is one more thing which we do basically here. So here in a for loop, we create the reference of all models available in regression. And then for all models, we calculate the prediction and test data, all the statistics that we will now learn. We will calculate it for every model, and then we will compare for the best value or the best model performance metrics out of all the models, and whichever model is giving the best performance evaluation metric, we select that model at last. That is
Okay.
how practically we do when we are implementing the use cases in ML. You
Mhm.
are getting the point, right? So here right now, so I am just creating one model, right? So model equal to linear regression. So this is like creating a reference variable or an object of a linear regression model. Then I can create model 1 equal to lasso regression. Similarly, I will create till model n, whatever is available in machine learning, I will create for decision tree regression. And then for each of these model 1 to n, model 1, model 2 till model n, we will be having some performance evaluation metrics, right? Let's call it as PEM, performance evaluation matrix 1, performance evaluation matrix 2, and it will be till performance evaluation metric n. So मॉडल 1 से परफॉर्मेंस इवेल्युएशन मैट्रिक 1 आया, 2 से 2 आया, n से n आया, right? Now out of all these performance evaluation metrics, whichever is the best performance evaluation metrics coming number wise, let's say it is coming for model 2. So at last we will select model 2 by using simple condition statement if else, because performance evaluation matrix 2 is coming best out of all the models that we have created.
So how
And
do we
then,
know which is the best? Do we
yeah,
have
that
any
is,
algo to find out?
no, that is where we have to study statistics.
Okay, okay.
So
Yeah.
statics is, so once we select this performance evaluation matrix, we will select model 2 in this case, and then using the model 2 reference variable or object, we will calculate all these, we will do the prediction, we will calculate the coefficient, intercept, and all those things. So this
Yeah.
is how generally we basically do.
Yeah.
So statistics, let's cover or should we cover it in next class? Statistics may see there are a lot of things. I will just, okay, let me give you an example what we will be covering, and then we can, because this is a little mathematics that we have to do in this case. So I'll just give you the idea what we are going to cover in statistics. So you guys might have already heard about it, right? That statistics is the backbone of machine learning, right?
Yeah.
Okay, so as part of statistics, we will see what is error, what is absolute error, what is squared error, then we will see deviation, then we will see squared deviation, we will also see absolute deviation, then we will see mean absolute error, we will also see residual sum of squares, we will also see total sum of squares, what else? Mean absolute deviation, then we will see coefficient of determination, we will see mean squared error, then root mean squared error, we will see population variance. Okay, so there are a lot of things, right? We will also see sample variance, we will also see what is standard deviation. Okay, and we will see so mean squared error, root mean squared error, and mean absolute error. For this, we will see how do we calculate the percentage of it. So, and when we will be evaluating the models, we will be considering these mean absolute deviation, mean squared variable, sorry, mean absolute error, not deviation, sorry, mean absolute error. We'll be seeing mean absolute error, mean squared error, and root mean squared error, as well as coefficient of determination. So we will be calculating these 3 to 4 statistical attributes to evaluate models. Now, what are these attributes? How do we calculate it? And how do we calculate in Python way? And then how do we basically evaluate models based on these attributes, and then decide whether our model is it's a good fit, or it's a overfitting, or it's a underfitting model. We will see that in next class. So you have a week now, right? So what you can do, if you will be practicing, take an example of simple linear regression as well as multiple linear regression, and build a code map, whatever I have taught you today, and try to do Python code, hands-on Python code from your own side. If you'll do it, couple of times, you will become comfortable in that. Okay. So multiple linear regression also, if you can think of some unique case, then well and good. Otherwise, you can, ask from ChatGPT also. It can give you a lot of cases, multiple linear regression. So try to, implement linear regression and multiple linear regression, just basic flow that we have seen in today's video. And then in next class, we will be covering the statistic part, and then performance evaluation metrics. How do we calculate that? How do we calculate for overfitting, underfitting? What is overfitting, underfitting? What is good fit? And what happens when the model is overfitting? What step we need to take in order to reduce the overfitting? What step we need to take in order to reduce the underfitting? And once we'll learn all these concepts, then we will take one example and build a complete machine learning pipeline for linear regression model. Okay, cool. I think that's pretty much it for today's video. Any suggestion, anything that you want to share? How's today's video? Whatever is taught, is it understood?
Yeah.
Okay, now slowly you are moving into the world of machine learning and deep learning. So, I mean, generally people don't teach machine learning and deep learning as part of generative AI training, but according to me, you should be knowing the basic concept, how actually the machine learning and deep learning works before you jump onto the generative AI concepts. So machine learning itself will, if I would say, it will take around 25 to 30 hours of training. If we are looking to learn machine learning in a very detailed manner, but uh, I'm trying to teach you as much as I can in short span of time, without compromising with the quality. So let's see how we can implement statistics from next session onward. So once we will complete the regression part, we will uh, jump onto the classification. And when we'll cover regression and classification, we will be done with the foundation of supervised learning. And after that, we will, study unsupervised learning, and then we will jump onto the deep learning. And deep learning, we will not go much in depth. I will give you the idea about how the deep learning work, and then we will quickly, start our generative AI, which is basically, the most important part of this training. So I want to spend more time on generative AI piece, but before that, I want to make sure that you are understanding all these concepts. Okay, cool then. Thank you guys. See you next week. Have a happy weekend.
Thank you.